morning. So this is our second lesson in polar equations. And today it's going to get a lot more interesting than yesterday's polar equations. And we are going to start graphing some different kinds of equations. So we're graphing by hand. And incidentally, had we been in class, we would have spent a whole day, graphing these by hand, and then we would have spent another day just playing with the calculator, because the polar equations are super fun on the calculator as well. So that might be our next lesson. Okay, so if we graph by hand, it's really nice to just keep this in mind. So let's do this in pink here. Keep the sine graph in mind. Okay, so remember polar has r and theta, so we're going to be using some trig functions today. So, and you remember what sine looks like because we spent so long studying trig. So, but it's kind of nice just to have it up here. So here, 1 and -1, and that occurs at 90 and 270. And we're at 180, we're at 0. And 360, we're at 0. So that's kind of nice just to keep in mind there. And then we'll put cosine over here as well. And that starts at 1 and dips down and comes back. Okay, so that's at 1, and that occurs at 0, and a -1 here. Can you see that? Yeah, okay, good. And then we're at 0 at 90 and 270 and -1. Oops, at 180 and back at 1 at 360. Okay, so now we kind of have those those at our fingertips now. And you could just keep the unit circle in your mind, but sometimes it's nice to have a visual as well. Okay, so there are 6 graphs, 6 types of polar graphs that we're going to learn. And the first one is nice and easy. It's a circle. And of course, last time we did a circle, and we can do a polar graph as a circle, is just r equals, right? And that gives us concentric circles around the origin. But this one will give us a different kind of circle. So we can do r equals a, which represents any number. You can put in any constant there, cosine of theta, or r equals a sine of theta. Both of these will give us a graph that looks like a circle. And this number, instead of being a radius, this number will be the diameter. So that a becomes the diameter. And I'll show you why that is. Okay? All right, so if we draw a little graph here, and this is a polar graph. So remember, so this is not x and y, these are degrees. So this is 0 degrees, this is 90 degrees, right? We're turning this way. This is 180 and 270. Okay, and anytime when we would do a graph on a Cartesian coordinate plane and we didn't know what the graph looked like, what could we do? Yeah, you're right. We would build a table, right? If we didn't know how to graph the parabola, we would do an XY table. Well, we're going to do the same thing here. We don't know what this graph looks like, right? So we're going to do, instead of an XY table, we're going to do a theta R table. Okay, so theta and R. And the graph we're going to do is going to be r equals 3 sine theta. So you can imagine that 3 is going to be our diameter, and I'll show you why that is. Okay, so what I would do is I would start out with the easy thetas. Okay, So we're going to start with 0, 90, 180, and 270 and see what happens. So 0, 90, 180, and 270. Okay, now if sine is, or if theta is 0, sine of 0 is absolutely 0. So we've got our first point, and I'm going to do it in pink so you guys can see. So our first point is at 0, 0. Okay, then at 90, here we are at 90, we're at 1, right? So 1 times 3 is 3 when we do sine of 90. Okay, so at 90 degrees, we have a radius of 3, so we're going to go out 3. 1, 2, 3 at 90. And then 180, we're back at 0. So we don't go anywhere. We come back here. 0. And then 270, sine is negative 1. So we're back. Instead of going down here 3, we're going negative 3 on 270. So we go negative 1, 2, 3, and we're back here. So what's happening, negative 3. What's happening is it goes out here and then goes out here, and then coming back it goes out here again, right? We do 2 loops, kind of interesting, 2 loops in one 360 circle there. So in one, I should say, one revolution in the theta, we do 2 circles. That's kind of cool. All right, how's that for a circle? And then cosine works the same way. Cosine, instead of being on this axis here, it'll be on this axis, right? Because cosine at 0 is 1. So you can see how that might change. All right, the next one is my favorite, of course, because it's pretty, and it's called the rose. Okay, so this is the general. Here, I'll box the general equations. All right, so R equals A cosine B theta, and R equals A sine B theta. So those are the general equations for a rose. And this A, just like this gave us the diameter, this gives us the length of the petal. Length of petal. Okay. All right, so we've got, let's draw our graph here. And we're going to do R equals 5 cosine 2 theta and see what that one looks like. Again, we're going to do our theta and R. Okay, so we're going to do 0. I'm going to put in 45s this time. 45, 90, 135. And we should be able to get a pattern going here, so to see what that is. Okay, so at 0, cosine is 1, so we get 5. At 45, so you can see what happens. 45, when we plug in 45 here, we actually get 90, which means we're at 0, right? And then at 90, plug in 90, we get 2 times 90, which is 180. And at 180, we're up here at negative 1, so that would be negative 5. And then 135, we're back at 0. And then at 180, we multiply that by 2, so we're back at 5. Okay, so let's see what this looks like. We're going to go 0. Remember, this is 0, 90, 180. Okay, 1, 2, 3, 4, 5, and we're going to put a dot. Okay, so we came out, we put a dot. Then at 45, we're back at 0. So it comes out and then comes back at 0 at 45. And then at 90, we're at negative 5. So we're actually, we go up at 90, but normally we would go up, but we were at negative, so we're going to go down, down at 5. and then we come back. 135, we're back at 0, and then at 180, we're at 5, and we just keep going. And this is actually to finish this out. We would go up to 5 and back down. And so it makes this really pretty flowery like thing, which is why it's called a rose, obviously. So this one, it's a little, instead of, having a really long table here, I'm going to give you some hints. So if B is even, so this number, if this is an even number, like we had 2, you get 2 times B for the number of petals. So B was 2 here, so that's why we got 4 petals. So if B is even, we get 2 times B number of petals. And if B is odd, you get the same number of petals as B. Odd, you get B petals. It's just the way the numbers work out there. And this is fun to play with in the calculator for sure. Okay, the next one is called a lemniscate. Kind of a really weird word. And this is a hard one. It's r squared is equal to a squared cosine 2 theta. And the other one is r squared equals a squared sine 2 theta. Okay, and those are the general form of it. Okay, so we're going to do r's here. And our one here is r squared is equal to 2 squared sine 2 theta. And notice this 2 is constant on these. Okay, so this would, so if I wanted to solve for r, I'd square root it, right? So it'd be the square root of 4 sine 2 theta. And this one's a little bit strange. So if I stick in a 0 here, it'd be sine of 0, it'd be 0. So we'd be at the origin again. Okay, so let's go ahead and do our table here. So 0, 0. If I plug in a 45, we're going to do 45 because it's 2 times. Then I get sine is 1, right? Sine of 90 is 1. Square root of 4 is 2. Okay, so that's going to happen at every 45, right? Or every other 45, I should say. So then we do 90, we're at 180, we're back at 0. So it's going to look something like this. It's going to start out here, go out to 2, that's 2 on this radius here, and then come back and go back out to 2 and back. So this one looks like a sort of a cockeyed infinity symbol, right? Okay, so the next 3 we're going to do in the next video. Okay, good job, guys.